All right. All right, so we're gonna do one more. And before we get to this one, I want to say when we do the reactions, make sure, because we're not doing it at school, and we're not using, things that maybe you don't know what you're using or what you're getting into. One of the reasons we balance the equation is so you can see like what are the products going to be. Are they going to be something that you don't want to be breathing in? Is it a reaction that you feel comfortable doing? So if it's something that you don't feel comfortable doing, maybe pick a different reaction or find a video of that reaction. So to that point, isopropyl alcohol, we're going to show the combustion of that one. So there's going to be a fire. If you don't feel comfortable, if your parents don't feel comfortable with you doing that in the house or at home, don't do that one, move on to a different one. So having said that, combustion of isopropyl alcohol, you're going to see this thing written as C3H8O. I think that's what it is. Now, part of the rubric is also looking at what happens on the molecular level. You got to understand that you might see a picture of this thing written like this, where there is this shape, and then the OH is off this side. Every one of these endpoints and the vertices are all carbons. Okay, all carbons there. And then coming off those carbons, so carbon is going to make how many bonds? It's in group 4. It's going to make 4 bonds, that's right. So going off of everyone, if one's already here, it's going to have 3 more bonds that it doesn't show in that picture, and those are the H's. H's. And then this one has 3, there's going to be one more off of there, and it's going to be in this tetrahedral shape. And one of oxygen's bond is going to be over here with that carbon, another one is going to be with a hydrogen. And for alcohol, all we really care about is this part right here. This is the alcohol. Okay? And so what's going to happen is that when we start that on fire,
wait, what?
With every reaction that's combustion, the number one thing that's going to tell you that it's a combustion reaction is all fires need oxygen. Okay? So what's going to happen with that is that oxygen is going to break apart, and you're going to get things like carbon dioxide and waters coming from the oxygen here binding with this hydrogen and that oxygen. Okay? All right, so like I said, if you don't feel comfortable doing some of these reactions, like this one is going to involve fire, don't do those. The same goes for if you're doing the textbook stuff, that's a little bit more authentic. You're doing a chemical reaction, you don't feel comfortable doing that one, or you don't have the supplies, move on to something else. Or, as we get further, if we are missing each other for more than this next week after spring break, some of them ask for a microscope. If you don't have a microscope, don't do that one, just move on to something else. Okay? So here's the isopropyl alcohol. One of your vocabulary words was bond energy. So it still does have an energy in its bonds, and to get that bond to break with the oxygen that's in the air, to get this reaction to go, we need to add a little bit of energy. That little bit of energy is going to kickstart that reaction, and then it's going to have enough energy to keep that reaction going on. So bond energy is the energy between bonds. I need to add a little to break these bonds. You get some back when they get remade. If you get more back than what it cost you to break them, that's going to be exothermic. If it took more to break them, it's going to pull energy in, and that would be endothermic. But we're going to get more back at the end here. That reaction is going to keep on going. This one's going to be exothermic. Okay, go ahead. And so that will burn as long as there's alcohol in there. So it's 91% isopropyl alcohol. So there's some water in there, but that 91% isopropyl alcohol will keep burning as long as the alcohol is in there.